Okay, so proceed tayo dito sa ating proving technique. So una is lesson 5. So proving technique. So may actually tatlong klase ng proving technique: by mathematical induction, by indirect and indirect proof, sa tawag dito contradiction, tapos yung lastly proof by divisibility. Okay, so tuturo pa sa number theory, kaya medyo happy awan ko siya kasi kailangan ko siya ituro. Tapos kung napansin nyo, may sulat na. To be honest, nag-take na ako, nag-shoot na ako niyan, kaso nangyari unsupported file, tapos nasulatan, tapos nag-run out na rin ako sa papel, so hindi ko na siya ma-reprint. So ang gagawin, since verification pa naman siya, i-explain ko na lang ulit paano nangyari. Okay, although hindi pa naman yun yung pinaka-importanting part. Okay, so ulit pasensya na, hindi ko na masyado ma-reproduce yung video niyan, unsupported kasi yung nangyari. Okay, so sabi, show that 1 plus 3 plus 5 plus plus 2n minus 1 is a perfect square. So anong ginawa ni sir? Para mas papakita ko na perfect square yung part na yan, ginawa ko, in-equate ko siya sa n squared. Okay, that's 1 plus 3 plus 5 plus plus 2n minus 1 is equal to n squared. One way para mapakita kong perfect square siya is equate ko siya sa n squared. Okay, ngayon, ano ibig sabihin ng left side saka sa right side? So, ibig sabihin ng left side, for example, yan yung number of term. For example, n is equal to 1, isang term gagamitin ko. O isang term sa series. So, parang that is 1. Then, sa kabila naman sa n squared, dun ko na isa-substitute yung 1. Okay, for example, n is equal to 2, that is 1 plus 3 equals sa n squared. n is equal to 3, that is 1 plus 3 plus 5, okay, equals sa 3 squared. So, ulitin ko lang. Sabi, ito yung unang step sa proof of induction. So, step 1, verification. So, again, ito yung proof niya. So, step 1, verification. So, unang ginawa ko, for n is equal to 1. So, ang tanong, sir, lagi bang n is equal to 1 and 2? So, for the meantime, yung mga makikita mo example ko, nagbe-verify ako for n is equal to 1 and for n is equal to 2. Pero may mga cases kasi, kunyari, naglagay dito ng set ng parameter, parang for n is equal to 3, so magi-start ka, or for n is greater than or equal to 3, magi-start ka sa 3, then 4. May mga ganun scenario kasi. Okay, pero for the meantime, ang laging sure, for n is equal to 1 and 2. Okay, so sabi nga ng verification, so una, for n is equal to 1, ang ginawa ko, sa left side, ang kinuha ko lang is 1. Okay, then pagdating sa right side, ginawa ko 1 squared. Ipinalit ko yung 1 sa n squared. Then, anong nangyari? 1 is equal to 1, which is true. So, ang goal kasi ng verification, mapatunayan mo na true yung equation o yung statement. So, by using values. Next, for n is equal to 2, ito na yung sinasabi ko. Dalawa yung values. So, for n is equal to 2, yung right side, pinalitan ko ng 2, kaya 2 squared. Pero sa left side, naging 1 plus 3, meaning dalawa, 1 plus 3, dalawang term. So, for n is equal to 3, anong gagamitin ko? 1 plus 3 plus 5, that is 9, equals sa 3 squared, that is also 9, which is true. So, dito, nangyari dito, 4 is equal to 4, kaya true. Okay, yun yung purpose ng verification. Sir, laging ganyan, usually ito pag summation, or pag sum. Okay, so again, sa verification, pahig ako for the meantime, for n is equal to 1 and 2, dalawa lang. Dalawang verification, okay na ako dun. Okay, since sa number theory ituturo pa to, so kailangan ko lang ituro kasi somewhere sa mga proving natin or mga discussion, gagamitin ko yung induction eh. So, mas mabuti nang alam mo. Ngayon, step 1 is verification. Daan. Step 2 is what we call the induction hypothesis. So, step 2, the induction hypothesis. Sir, ano po yung induction hypothesis? Okay, so, ang gagawin naman sa induction hypothesis, magle-let ka lang, ililet mo, yung n ko is equal to k. So, wala kang ibang gagawin, papalitan mo lang yung n na is equal to k. So, yung 1 plus 3 plus 5 plus plus 2n minus 1 is equal to n squared. Lahat ng n, papalitan mo lang ng k. So, mangyari, this is equal to 1 plus 3 plus 5 plus plus 2k minus 1 is equal to k squared. Okay, so ano purpose ng induction hypothesis? Ang purpose kasi ng induction hypothesis, somewhere sa proof gagamitin ko siya mamaya. Okay, ito yung gagamitin ko mamaya sa proving natin. So may kita mo, okay, yun yung gamit niya. Okay, so next, proceed tayo dito sa susunod kong gagawin. Sir, ano pong susunod mong gagawin? So, induction hypothesis, let n is equal to k. So, mamaya gagamitin ko lang siya. Para lang siyang assume. So, gagamitin ko doon. Isa-substitute ko lang mamaya. Okay, so step 3. Step 3 is the proof of induction. So, ano naman meron sa proof of induction? Sa proof of induction, ililet mo na si n is equal to k plus 1. So, ano ibig sabihin ba nung k plus 1? Sa left side, ang ibig sabihin ng plus 1, magdadagdag ako ng isang term. Sa right side, gagawin ko lang k plus 1. So, ano ibig sabihin nun? Sa left side, ito mangyari. This is 1 plus 3 plus 5 plus dot plus. Ilalagay ko pa rin si 2k minus 1. Okay, kasi yun yung k. Then, maglalagay ako ng k plus 1. So, that is plus multiplied by 2 times k plus 1 minus 1. Okay, equal to sa k plus 1 squared. Yun yung ibig sabihin ng k plus 1. Hindi right away na yung n lang papalitan ko ng k plus 1. O ulit sa right side ang gagawin ko, nagdagdag ako. Aside from k, dinagdagan ko siya ng 2k plus 1. Ayun yung part na yun. Okay, ngayon, ano bang gagawin dito? So, pipili ka dyan. It's either mula dito, ipuprove na papunta doon. Or mula dito, gagawin mong ganon. So, akin, ang pipiliin ko, yung left hand side. So, consider natin. Okay, so consider. Si 1 plus 3 plus 5 plus dot plus 2k minus 1 plus, solve ko na to. This is 2k plus 2 minus 1. Okay, so ang goal ko, kailangan at the end ng proof maging k plus 1 raised sa 2 siya. So, proceed tayo. So, this is equal sa 1 plus 3 plus 5 plus dot plus 2k minus 1 plus this is 2k. Okay, then 2 minus 1 is plus 1. Okay, that is equal sa part na yan. Okay, so another, kung napapansin mo, itong part na to, okay, yan ginuhita ni sir, siya ay by assumption o yung induction hypothesis natin, siya daw ay equal kay k squared. So therefore, papalitan ko siya ng k squared. This is equal sa k squared plus 2k plus 1. Okay, then by factoring, that is equal sa k plus 1 raised sa 2, which is ito. Okay, so therefore, so 1 plus 3 plus 5 plus dot plus 2n minus 1 is always a perfect square, and this is done. Okay, so we use PMI. This is principle of mathematical induction or proof of mathematical induction. Okay, so ganun yung goal. So tandaan, pwedeng dito ka mag-start, expand mo siya, papunta doon, papunta sa kabila. So pinaka-convenient way kasi yung left side eh. Mahaba siya, magagamit ko to. Okay, so proceed tayo sa number 2 para mas makita mo yung verification. Okay, sorry, naisipan din ako. Okay, so prove that the summation of I for I is equal to 1 up to n is equal to n times n plus 1 over 2. So, aware ka naman ano yung summation. So, lalagay ko na lang ano ba ibig sabihin ng summation of I for I is equal to 1 up to n. So, that is start tayo sa 1 plus 2 plus 3 plus dot plus n is equal sa n times n plus 1 over 2. Okay, then medyo pasensya, lumiliit sulat na sir. Medyo nakakangawit din kasi ngayon. Okay, so kanina pa kasi nagbibideo rin. Okay, next is, siyempre, start tayo sa proving. So, anong sabi ng proof? Ito yung proof, step 1. So, kahit step 1 na lang ilagay mo, kasi understand na yun or understood na yun na verification. Okay, so step 1, for n is equal to 1. So, for n is equal to 1. So, anong sabi ko? Dahil summation. So, usually, pag summation, for n is equal to 1, sa left side, kino-consider yung term. Sa right side, is a substitute. So, this is equal sa, this is 1 is equal to 1 times 1 plus 1 over 2. Tama. And that is equal sa 1 is equal to 1, 2 over 2 which implies that 1 is equal to 1, which is true. Okay, then for n is equal to 2, that is 1 plus 2, which is equal sa 2 times 2 plus 1 over 2. Okay, and this is equal sa 3 is equal sa 2 times 3 over 2, which is equal sa 3 is equal to 3, which is also true. Tama naman, no? 2 times 3 divided by 2 is also 3. Okay, so next is induction hypothesis. So step 2. So step 2 is the induction hypothesis. So ano gagawin sa induction hypothesis? Ililet ko na n is equal to k. Okay, so that is let natin na si n is equal to k. So mula doon magpapalit lang tayo that is equal sa 1 plus 2 plus 3 plus plus k is equal to k plus 1 all over 2. Okay, so somewhere mamaya sa proof gagamitin natin yan. Okay, then step 3, lagay ko lang dito. So step 3 sa proof of induction. Para sa proof induction, ililet ko na si n is equal to k plus 1. So again, alam niyo ibig sabihin yan, kung nagkaroon ako ng k dito, dadagdagan ko siya ng k plus 1. So this is equal sa 1 plus 2 plus 3 plus plus k plus k plus 1. Ito yung part na yan. Okay, equal siya sa, ito magiging k plus 1. Tama? Then magiging, yung isa, magiging k plus 1 plus 1. Okay, all over 2. So literal, that is equal sa k plus 1 times k plus 2 over 2. Okay, so ang goal natin mula dito dapat naging k plus 1 times k plus 2 over 2. Okay, so proceed tayo dun sa part na yan. So consider natin sa left hand side, o you see ano. So consider C 1 plus 2 plus 3 plus plus k plus k plus 1. Okay, so aware kayo na itong part na to ay equal sa part na to, k times k plus 1 over 2. So this is equal sa k times k plus 1 over 2 plus k plus 1. Tama. Next is, aware kayo pag cross multiply, this is equal sa k plus 1 plus 2 times k plus 1 all over 2. So, rule ng fraction. Pag nag-add tayo ng fraction sa whole number. So, nag-cross multiply lang ako dyan. Next, may common factor yung numerator na k plus 1. So, therefore, by factoring, this only implies that k plus 1 times may matitirang k dito plus may matitirang 2 doon all over 2, which is ito na. Okay, so therefore, summation for I is equal to 1 up to n ng I is equal to n over n times n plus 1 all over 2. And this is done and we use PM. Okay, so ayan yung process nung number 2. Again, sa proof of induction, ang gagawin mo, verification for n is equal to 1 and 2. So again, hindi laging 1 and 2, depende sa restriction. Pag sinabing n is greater than or equal to 3, mag-start ka sa 3, then 4. Okay, then step 2 is induction hypothesis. Ililet mo lang na si k and si n is equal to k. Then step 3, proof of induction, let n is equal to k plus 1. So yung left side mo, dadagdagan ng it's either k plus 1 term. Yung isa naman is substitute ko lang k plus 1. Then ang gagawin ko sa proof of induction, consider mo pinaka-safe lagi sa left hand side o yung left side. Then i-show mo siya papunta sa right side. Okay, so ayun yung goal ng mathematical induction. So proceed tayo sa next proving technique. Okay. Okay, so next proving technique is the direct, indirect, and the proof of contradiction. So, ano ba si direct proof? So, explain ko lang ha. Ano ba si direct proof? Okay, sir. Si direct proof, that is P implies Q. And dati, assume si P show Q. Si indirect proof, yun naman yung inverse. That is not P implies not Q. Okay, then proof by contradiction, ipapasok mo naman yung Q, gagawin mong not. Tama? Sa contradiction or sa RIP, ipapasok ko yung Q, magiging not Q, tapos mag-show ka ng 0. Okay? So, ito yung number 2. So, usually magtataka, sir, ano naman ginagawa? Ngayon naman, ang usapan natin, element argument tayo using yung mga integers. Usually, integer yung gagamitin ko. So, ngayon, another natin na pag-uusapan, pag sinabi kong add, or pag sinabi kong integer, automatic, case 1, case 2. Case 1, even. Case 2, add, which is 2k plus 1 or 2k minus 1. Pili ka na lang. Excuse me. Okay, so yan ha. Yan yung gagawin. So pag integer, automatic 2k, even, 2k plus 1, add, or 2k minus 1. Okay, so try natin sa number 1. So show natin. Okay, sabi, if n is an even integer, show that 5n minus 3 is odd. So, dito pa lang isipin mo, assumption, n is an even integer. So, meaning, eksaktong isa siya. Hindi ka, pag sinabing sing n is an integer, pasok sa case 1, case 2. Automatic add and even, then i-prove mo. Dalawa na parehas add. Kasi ang nangyari dito, ito ay direct proof lang. Ito yung P implies Q. So, direct proof siya, wala ka nang ibang gagawin. So, paano gagawin ni sir dyan? Start tayo, ito yung proof. Okay, so since n is an even integer, ililet mo lang. Okay, so let n is equal to 2k. So, for some k element ng integers. Okay, sir, lagi may for some k element of integers. Yes, sir, but hindi for all? Ang ginagawa kasi, bakit hindi for all? For some, meaning some lang gagamitin, hindi lahat. Kasi pag for all, ibig sabihin, ginastify ko lahat eh. So, meaning lahat ginagamit ko. Dito pag for some, kunyari, for k is equal to 1, substitute 2. For k is equal to 0, substitute 0. For k is equal to negative 1, negative 2. Ganun lang. Yun ibig sabihin ni for some. Pag sabi for all, meaning ginamit ko lahat. 2, 4, 6, 8, 0, 10, 12, lahat yung ginagamit ko. So, parang dinadirect mo, directly lahat ginagamit ko. Kaya usually, pag ganito, pag nag-let ka, tas equal to 2k, for something yung follow-up. Okay? So, huwag nyo masyadong pansinin. Gagamitin din, yan din naman lagi yung gagawin nyo. Okay? So, proceed tayo. So, sabi, let n is equal to 2k, then for some k element ng integer. So, ang goal natin, i-show natin na si 5n minus 3 is add. So, consider natin si 5n minus 3. So, consider si 5n minus 3. Okay, so that is equal sa, sabi nung assumption, si n papalit lang ko ng 2k. Okay, that is minus 3. Saan galing yung 2k? Dun n is equal to k. Yun kasi inassume eh. Okay, next, this is equal sa 10k minus 3. Okay, ngayon, pansinin nyo sa loob dito. Sir, kailan po ba magiging add? Magiging add pag 2k plus 1 siya or naka 2k minus 1. So, ang goal ko dapat magkaroon dyan ng it's either. Dahil minus nakikita ko, siguro dapat minus 1. So, ang gagawin ni sir, ito, check nyo ha. Ang gagawin ni sir, this is 10k minus 2 minus 1. Tapos, i-group ko to. Okay lang? So, ang ginawa ko lang, dinidak ko lang ng yung minus 3 biniyak ko. Ginawa ko minus 1. Minus 2, minus 1. Okay, so wala ako ibang ginagawa. Ngayon, mula doon, magko-factor ako ng 2. Okay, so sa 10k minus 2, pwede ako mag-factor. So, magko-factor ako dyan ng 2. That is 2 times 5k minus 1. Minus 1. Okay, then lilet ko dito. So, let natin na si q is equal to 5k minus 1. Sir, ba't ka nag-let? Ito kasi dating. si k integers. So, si 5 times k, integer yun. Tama? So, 5 times integer is integer. Minus 1, which is integer. So, therefore, ano si q? Integer. Tama? Ulitin ko lang ha. Si k, saan galing? Sa integers. So, 5 times integer is also an integer. Minus an integer, which is 1. This is also integer. So, therefore, si q, integer pa rin yan. So, this implies that this is 2q minus 1. Sir, bakit ka ba nag-let ng q is equal to 5k minus 1? Kasi ang goal, kailangan naging katulad siya ng structure na 2k minus 1. So, hindi ko naman lagi sinasabing k. So, si 2q minus 1 is also a form in add. Tama? 2q minus 1. Si 2k minus 1. Si 2m minus 1. Add yun. Lahat yun, pare-parehas add. So, therefore, 5n minus 3 is add. Okay? And this is done. Okay? So, ang ginawa ko, from 5n minus 3, ipinalit ko yung assumption, sa dulo, naging add siya. So, 5n minus 3 is add. So, 2q minus 1 is add. Okay, so ganun siya kasimple. Okay, so number 2, ang sabi, if x is an integer, so pasok dyan yung case 1, case 2, so pwedeng add siya, pwedeng even, okay. Then sabi niya, show that x squared is even if and only if x is even. So, dun pa lang sa part na yun x squared is even if and only if x is even. So, anong nangyari? Ang goal, para siyang biconditional. Tama? If and only if kasi. So, ulitin ko lang ha. Ang nakalagay kasi, x squared is even if and only if x is even. Okay? So, we have case 1 and case 2. Case 1, x squared is even, show that x is even. Tama? Case 2, show that assume that x is even, show that x squared is even. Okay, so ngayon, punta muna ako doon sa case 2. Mamaya na yung case 1 ha. So, skip ko lang para makita natin yung madali. Okay, so sabi ng case 2, assume that x is even. Okay, so ano ibig sabihin nito? X is equal to 2k for some k element ng integers. Tama? Then, ang goal natin, or show that x squared is even. Okay, so paano yan? Consider si x squared. So, by assumption, that is equal sa 2k raised sa 2. Okay? And that is equal sa 4k squared. Note, paano ba siya magiging even? Magiging even pag 2 times something. Laging ganon. So, ang gagawin ko, pa-factor out ko dito si 2. That is 2 times 2k squared. Okay, pinactor out ko yung 2. Then, ilet ko lang na let q is equal to 2k squared. So, even yan, k is integer, k squared is integer, 2 times k squared is integer, therefore q is integer. So, therefore, this is equal sa 2q, which is even. Okay, so, x squared is even. Okay, so mamaya ako nitadan kasi magti-case 1 pa tayo. So, ang tataka ka, sir, bakit mo ba inuna si case 2? Yung case 2 kasi madali. So, sa case 1, medyo magic pa si sir. Okay? Okay, so case 1. Case 1, ano yung assume? Assume that x squared is even. Show that x is even. So, kung napapansin mo, dito kasi medyo may mahirap na part. Bakit? I-assume ko na yung case x squared is equal to 2k. Tama? So, ang mangyayari, mag-i-start ako kay x. So, ang gagawin ko sa x, hindi ko basta pwedeng palitan ng square root of 2k. Tama? So, pag palitan ko sa x ng square root of 2k, hindi ko mapapakita. So, ulit papakita ko lang sa scratch. Kasi ang gagawin mo, ganito no, ililit mo sa x squared ay 2k. Tama. Tapos ang mangyayari, consider mo si x, papalitan mo si x ng this implies that x is equal to square root of 2k. So, papalitan mo si square root of 2k. Hindi mo agad pwede sabihin na even yan. Tama? So, ang dating, parang imposible pag nag-direct proof tayo. Ang ginawa ko kasi sa case 2, direct proof lang. Okay? Ngayon, naalala mo ba si P implies Q? Si P implies Q may tatlong counterpart. Si inverse, si converse, saka si contrapositive. Among sa tatlong yon, saan siya equivalent? Equivalent si P implies Q. Ulitin ko lang ha. Equivalent si P implies Q kay not Q implies not P. Tama ba? Equivalent si not Q kay not P. Kasi ayan yung contrapositive. Pero hindi ko kasi agad sure na right away not P implies not Q. Hindi kasi laging equal yung truth values nun eh. Truth value nun eh. Tama? So, ang gagawin ko itong contrapositive. So, by contrapositive, iba i-assume ko. So, using contraplus or C+, so, ang bagong assumption ko, so, yung show, gagawin kong x is odd. Tama, kasi not Q eh. So, x is even, magiging not, so x is odd. So, show that x squared is odd. Yan yung goal natin. So, at least dito sa part na to, mas madali siya tingnan. Ngayon, mula dito, this is equal sa x is equal sa 2m plus 1 for some m element ng integer. Sir, bakit m? Gumamit na kasi ako ng k dito. So, para hindi laging redundant yung gamit ng integer, gamit ka ibang letter para ang elegant ng proof. So, gumagamit ka ng ibang variable, at least alam mo integer. So, ayun lang naman yung mga suggestion ko. So, consider natin dito, sabi ko nga, consider natin si x squared. Okay, so that is equal sa 2m, that is 2m plus 1 square. Okay, and that is equal sa 4m squared, tama, plus 4m plus 1. Okay, so ang goal natin, kailangan natin siya maging add lang. So, mula dito sa part na to, naglalabas ako ng 2. So, this is equal sa 2 times 2m squared plus 2m plus 1. So, ito na ginagawa ko. Mag-let lang ako. So, let P is equal to 2m squared plus 2m. So, therefore, this is 2p plus 1, which is odd. Okay? Since na-prove ko yun, so, therefore, x squared is odd. Since x squared is odd, so, lagay ko lang. So, x squared is odd. Although, hindi naman totoo. Kasi any number, erase ko sa 2, is even. So, ang ginawa ko lang, kinontrapositive ko lang. So, kumbaga, pinrove ko lang siya in contrapositive way. So, para siyang contradiction. So, ang i-show ko talaga, si P implies Q. So, this implies that x squared is even, then x is even. Ayun lang naman yun eh. So, ginamit ko lang si not Q implies not P para makita ko o ma-prove ko siya na totoo. Kasi nga, by conditional naman sila eh. Okay, so therefore, this is done. So, sir, pwede ba yon dito ibang proof? Yes, possible yon. Pwedeng mag-direct proof, indirect, contrapositive, plus inverse, possible yon. Case 1, case 2 naman. So, hindi naman nakaka-apekto sa isa't isa. Okay, then proceed tayo sa number 3 para makita nyo naman yung kakaiba. Okay, so for number 3, ano sabi? If n is an integer. So again, hindi siya specific. So hindi natin alam kung odd, hindi natin alam kung even. Okay, so probably, or to be honest, tayo ay mag-case 1, case 2. Case 1, odd siya, case 2, even. Or case 1, even, case 2, odd. So ikaw na discarte mo. Ngayon, show that n squared plus 3n plus 5 is odd. Okay, so this is the proof. Okay, so case 1, so, let natin na si n is 2k. Okay, for some k element ng integers. Okay, then i-consider natin. Consider si n squared plus 3n plus 5. Ang goal natin dapat maging add siya sa dulo. So paano magiging add? It's either 2k minus 1 or 2k plus 1. So dapat either sa dalawang form na yun. So this is equal sa 2k raised sa 2 plus 3 times 2k plus 5. Okay, then simplify further. This is equal sa 4k squared plus 6k plus 5. Okay, so obviously dun sa dulong part yung constant, dun tayo magbibiyak. Kasi ang goal natin, kailangan magkaroon ng 1. Since add yung 5, so hiwalay ko lang yun dyan yung 1. So this is equal sa 4k squared plus 6k plus 4. Okay, then plus 1. Then wala dyan, syempre pa-factor out ko 2 kasi nga kailangan natin 2 something plus 1. Okay, so factor out natin this is 2 times 2k squared plus 3k plus 2 plus 1. So ilet ko lang na p 2k squared plus 3k plus 2 kasi nga even ng integer yan. Yung k integer, therefore yung p is also an integer. So therefore this is equal sa 2p plus 1 which is add. Okay, so n squared plus 3n plus 5 is add. Okay, so ganun siya kasimple. Ngayon, case 2. Paano yung case 2 natin? Sabi ng case 2, let natin na si n is equal to 2m plus 1. So, for some m element ng integers. So again, iniiba ko lang letter para maging elegant siya. So hindi redundant yung dating. Kasi nga kung ginawa ko siyang k, so meaning dito lang din ako galing. Okay, ginagawa ko lang siyang elegant. So consider ulit natin. Consider n squared plus 3n plus 5. So this is equal sa 2m plus 1 squared plus 3 times 2m plus 1 plus 5. Okay, then pag in-expand si 2m plus 1 squared, that is equal sa 4m squared plus 4m plus 1. Okay, then this is plus 6m plus 3 plus 5. Okay, simplify further. This is equal sa 4m squared plus 10m plus 9. Ngayon, ang goal natin, since add naman yung lumabas na constant, so probably hahatiin natin ulit yan. So, this is equal sa 4m squared plus 10m plus 8 group, then plus 1. Okay, then nag-factor out ko na 2. That is 2 times 2m squared plus 5m plus 4 plus 1. So, mag-let tayo na iba. So, let q. So, let q is equal to 2m squared plus 5m plus 4. So, this is equal sa 2q plus 1 is add. Okay, so, n squared plus 3 plus 5 is also add. Okay, for n is equal to add integer. Okay, so therefore, this is done. Okay, so ganyan naman pag ang ginawa natin direct proof, wala tayong ibang ginawa. So direct lang. So assume, show, assume, show. Okay, then proceed tayo sa last example nito. Okay, so let's proceed to example 4. So sabi, show that the square root of 2 is irrational. So pahirap ka, no? Sir, ano yun? Gagawin. So dito sa part na to, ang gagawin ko, proof by contradiction. So anong gagawin ng contradiction? Ipapasok ko yung conclusion, gagawin kong not. So, ang gagawin ko, proceed by contradiction. So, ito yung proof. So, we will proceed by contradiction. So, anong gagawin? So, isi-show ko. So, suppose that or assume that square root of 2 is rational. Okay? So, since square root of 2 is irrational, then, pwede ko sabihin, then, si square root of 2 is equal sa P over Q. Okay? Where si P and Q is element ng integers and Q is not equal to 0 and P and Q have no common factor or factors, sorry. So, ulitin ko lang ha. Nag-proceed ako by contradiction. So, ang pinapaprove, show that square root of 2 is irrational. So, ang ginawa ko, ipinasok ko siya. So, ginawa ko, assume that square root of 2 is rational. Since rational siya, ano sabi ko dati ng algebra, pag rational ako yung number na kung saan kaya mo kong i-represent as a fraction. Ngayon, anong klaseng fraction yun? Yung fraction na yun is P over Q. Na yung P over Q, yung P and Q is integer. Yung Q, hindi 0. Tapos, yung P and Q have no common factor. Ano ibig sabihin pag yung P and Q have no common factor? Meaning, naka-lowest term na. So, kunyari, yung 2/4 wala dyan. Ang meron nandiyan 1/2. Okay, so ulitin ko. Si square root of 2, ginawa ko lang siyang rational. So, ang goal natin, paano ba sa contradiction? Sa contradiction, hanap ka ng P. Okay, so, hanap ka ng P, hahanap ka ng not P. Tapos, pag nakahanap ka ng not P, yun yung term na masabi mo. Kunwari, somewhere sa pag-prove, nakahanap ka ng not P. So, meaning contradiction dun sa ibang statement na sinabi mo. So, may statement na akong sinabi dyan. So, somewhere dapat nakahanap ko ng statement dyan na kung saan mako-contradict yung isang statement. So, pag na-contradict yun, so yun yung sinasabi ko, contradiction. Therefore, 0 siya. So, meaning, magkakaroon ng 0 dyan or ng conjunction na P and not P, that is contradiction. So, ulitin ko lang, hanap lang tayo ng statement somewhere sa proof na kung saan i-contradict niya yung ating mga masasabi dito. Okay, so consider natin to. So, check natin ano ba yung mga magagamit natin. So, consider si square root of 2 is equal to P over Q. Okay, so pag in-square ko both sides, ano mangyari? So, that is equal sa 2 is equal sa P squared over Q squared. Tama? And that is equal sa 2 Q squared is equal to P squared. Okay, ngayon, ano masasabi mo kay P squared? Okay, ulit ha, ano nangyari? 2Q squared is equal to P squared. So, ano masasabi mo kay P squared? Si P squared, by previous example, ang sabi, if x squared is even, then x is even. So, ano masabi? So, if P squared is even, then P is even. Tama? So, si P, pwede ko represent na P is equal to 2K for some K element ng integer. So, ulit ha, ang kinuha ko lang si P squared. Okay? Next. Pagdating dito, sa 2Q squared is equal to si P, papalit lang ko ng 2K. So, this is 2K raised sa 2. So, this is 2Q squared is equal sa 4K squared. Then, divide both sides by 2. This is Q squared which is equal sa K squared. Ngayon, ano nangyari? Kanina kinuha ko si P squared. Tapos, na-conclude ko by previous example, si P is even. So, dito, Q is also even. Tama? Kasi by previous example. Okay? Ngayon, anong masasabi ko? Pansinin nyo ha. Si P and Q, tignan nyo mabuti. Since P and Q is both even, are both even, so they must have a common factor, which is 2. Okay, so ngayon, lalagyan ko ito ng parang ganitong term. So, this implies na parang siyang contradiction. So, tingnan nyo ha, bakit? Diyan kasi ako nakita ng contradiction. So, bakit sir? Pansinin yung statement. Assume that square root of 2 is rational. Then square root of 2 is equal to P over Q, where P and Q is element of integer and Q is not equal to 0. And P and Q have no common factor. Again, P and Q have no common factor. But, since P and Q are both even, they must have a common factor which is 2. So, contradicting yung dalawang to. Itong part na to, saka ito. Kung ito yung P, ito yung not P. Since nakita ko ng contradiction, therefore, square root of 2 is irrational. Okay, and that is done. So, ganun kasimple pag contradiction. So, inanegate ko, maglalagay ako ng konting statement, then maghahanap ako ng konting solution doon. So, pag nakita ko ng statement na kung saan magkakaroon siya ng contradiction, then doon ako mag-assume na okay, mali siya. Okay, this is true. Okay, this is true by contradiction. Okay? So, yan yung way, yan yung technique natin na pangalawa, which is direct proof, indirect proof, contradiction, tapos yung contrapositive, tapos inverse. Okay? So, proceed tayo doon sa last part natin. So, last proving technique, yung proof by divisibility. Okay? Okay guys, so yung last natin na proving technique is the proof by divisibility. So, ano ba yung divisibility? So, before kasagutan si 1 and si 2, ano ba si divisibility? So, si divisibility, siya yung baliktad na divides. So, for example, ito yung definition. For example, meron akong A divides B. Okay, meaning yan divides, guhit na ganon. That is if and only if B is equal to A times K for some K element of integers. So, ulit ka lang. Pag nakita mo yung A divides B, that is if and only if B is equal to A times K. So, pag nakita mo yung B is equal to A times K for some K element na integers, that is A divides B. So, ano ba ibig sabihin ng A divides B in terms of number? In terms of number, siya yung baliktad, in terms of very simple sense, siya yung baliktad na division. So, dati, pwede mo sabihin na 8 divided by 4. Okay, so sorry. Ulit pwede mo sabihin na 8 divided by 4. So, ayun yun. Kunyari, 4 divided by 2. Ngayon naman, paano ko naman gagawin divides yung 8 divided by 4? So, ngayon, dati, yung 8 divided by 4, equivalent siya sa 4 divides 8. Okay? So, ulit 8 divided by 4 is 2. 4 divides 8 is also 2. So, yan yung baliktad na idea nung divisibility. Tandaan yan Okay. So, ibig sabihin nito, this is equal sa 8 is equal sa 4 times 2. Yun naman yung ibig sabihin yan in terms of divisibility. Okay. So, ulitin ka lang Ito yung importante. A divides B if and only B is equal to A, K for some K element ng integers. So, sir, pwede ba ibang letter yung K or integers? Yes, pwede. Pwedeng M, pwedeng N. Basta, as long as sinidefine mo na element siya ng integers. So, ulitin ko lang Hindi ko masyado siyang i-expand kasi nga ituturo din naman siya sa number theory. So, somewhere din sa dulo natin dito may ituturo ko pa siya. So, gusto ko lang siya gamitin kasi sasamahan ko siya mamaya ng proof of induction Okay? Then, magbasahin siya nyo medyo siguro yung mga video later ngayon yung lesson 4, lesson 5 medyo may mga background tapos nakikita nyo umalis ako so nag-shoot kasi ako nito for about 6 hours na rin ngayon so tagal ko na rin siya sinut so medyo talagang nahirapan ako dito kasi nga pause ako, inuubo minsan so talagang kailangan kong pahinga din. Okay, so ang goal ko lang sana maintindihan nyo yung topic. Okay, so proceed tayo dito. So, number 1, let A, B, and C element ng integer such that si A and B are non-zero. Show that if A divides B and B divides C, then A divides C. Okay, so may assumption tayo, dalawa. A divides B and B divides C. Then, ang proof natin, ay show natin A divides C. So, ito yung importante. Gagamitin natin yan. Okay, so ito yung proof. Okay, so yung mga assumption natin yung assume. Assumption na lang. So, una, A divides B. Tama ba? A divides B, that is if and only if. So, B is equal to AN. for some n element ng integers. So, ibang letter ginamit ko. Okay, next. B divides C. That is if and only if C is equal to B M. That is for some M element ng integers. So, iba ulit yung ginamit ko. Okay, so we need to show that A divides C. So, ang goal natin, kailangan maging A divides C siya sa dulo. So, i-consider ko tong part na C. So, consider natin si C is equal to B times M. So, nag-start ako din dito. Okay, next. Ang sabi nito, B is equal to AN. So, pwede ko palitan yung B dito. So, this is C is equal to yung B. Papalitan ko ng AN times M. Okay, then associative lang konti. That's equal sa C is equal to A times NM. Okay, then ililet ko lang. So, ililet ko lang na si NM is equal to K, element of integers. So, tama. Product ng dalawang integer is also integer. Okay, so next, that is equal sa C is equal to A, K. Which is, pasok na dito. B is equal to AK. B is equal to AK, that is A divides B. C is equal to AK, that means A divides C. So, this implies that A divides C. And that is done. Okay, so pansin mo no sir, ang dali pala ng divisibility. Medyo madali siya. Ngayon try natin haluan natin siya na induction. So ito pa yung another. Possible kasi na naghahalo-halo siya eh. So may divisibility siya. Gumagamit ka ng idea ng divisibility, plus ginagamit mo yung proving ng mathematical induction. So proceed tayo sa number 2. So itong number 2, show that 81 divides 10 raised to n plus 1 minus 9n minus 10 for n is greater than or equal to 0. So, kung titignan mo, no, for n is greater than or equal to 0. So, obviously, ito ay mathematical induction. Kasi mag-i-start ka for n is equal to 0, 1, 2, 3, 4, blah, blah, blah. Okay, pero may idea ng divisibility. So, ito yung proof niya. So, ano ulit nun sa mathematical induction? So, step 1. Okay, step 1 is verification. Tama. So, ngayon, nangyari, may restriction. May condition. So, ang condition, for n is greater than or equal to 0. So, possible, hindi ka mag-i-start sa 1. Mag-i-start ka sa 0. So, for n is equal to 0, tama. For n is equal to 0, this is equal sa 81 divides 10 raised to 0 plus 1 minus 9 times 0 minus 10. Okay, then this is equal, this is equivalent sa 81 divides 10 raised to 1 minus 0 minus 10. Tama, and this implies that 81 divides 0. Ngayon, tama ba yan? Is 0 divisible sa any number? Yes, 0 divided by 4, 0 divided by 7, 0 divided by 8, 0 divided by negative something is always 0. So, 81 divided 0 is 0. Okay, so this is true. Okay, next. For n is equal to 1. So, that is 81 divides 10 raised to 1 plus 1, that is 2 minus 9 times 1. Okay, then minus 10. Okay, then that is 100 minus 9, 91 minus 10, that is 81. Tama ba? So, pag kinumpute, this implies that 81 divides 81. So, any number is divisible by itself. Tama naman yan. Okay, so again, idea lang ng divide siya. So, next, step 2. Step 2, the induction hypothesis. So, paano ulit yung induction hypothesis? Sir, si induction hypothesis, possible po siya pag nilet natin si n is equal to k. So, yung 81 divides 10 raised to k plus 1 minus 9k minus 10. Ayan na po yung magiging mangyari. Ngayon, gagamitin ko na yung idea ng divides, that is A divides B if and only if B is equal to AK. So 81 divides yan something, so that is, this is if and only if 10 raised to K plus 1 minus 9K minus 10 is equal to 81. Let's say Q. For some Q element ng integers. Tapos yung minus 10 na yun, lagay ko pa sa kabila. So this is 10 raised to K plus 1 minus 9K is equal to 81Q plus 10. Okay, so gagamitin ko sa summary yan. Ayan, punta tayo sa may proof of inductions, step 3. Okay, so step 3, proof of induction. Okay, so paano naman sa proof of induction? Let n is equal to k plus 1. Okay, so that is let n is equal to k plus 1. So, ang gagawin natin, this implies that 81 divides, ano yun? 10 raised to k plus 1, no? So, that is 10 raised to k plus 1 plus 1 minus 9 times k plus 1 minus 10. Tama. Okay, then that is equivalent sa may common factor, that is 9k. Wait, check ko. That is 81 divide something na yan. Okay, so that is equal sa, that this implies 81 10 raised to 10k plus 2. Tama ba? 10 raised to k plus 2. Okay, minus 9k minus 9 minus 10. Okay, so ang goal kasi natin somewhere magamit natin itong nasa taas eh. Okay, next is, that is minus 19, I guess. So that is equivalent to, check ko lang so medyo napapaisip siya. Simplify further. This implies that 81 divides 10 raised to ipa-factor out ko dito si okay, that is ipa-factor out ko dito si k plus 2 minus 9k minus 19. Okay, so ang goal ko kasi magamit ko dapat yung assumption sa taas. Okay, so check ko lang, hanap ako ng pwede kong gamitin na value. Si 10 raised to k plus 2 pwede kong gamitin. Wait, check ako lang pwede kong gamitin. Okay, may napansin ako dito. So ito, ulitin ko lang, this is 10 raised to k plus 1 is equal sa 81q plus 9k plus 10. So ano ginawa ko sa taas, yung minus 9k ginawa ko pa dun plus. Okay, ngayon, ang gagawin ko dito, mag-extract ako dyan ng 10 raised to k plus 1. So, hiwalay ko yung isang 10. So, ito yung dapat ko kasi gagawin. So, this is 81 divides 10 raised to k plus 1 times 10. Okay, yan yung i-extract mo isa. So, minus 9k minus 19. So, sir, paano naging 10k plus 1 times 10 yan? Yung 10k plus 2, that is 10k plus 1 plus 1. Okay, hiniwalay ko yung plus 1 na isa. So, by rule of exponent. So, this implies, okay, so this implies that 81 divides, yung 10k plus 1, ito ay 81q by induction hypothesis plus 9k plus 10 multiplied by 10 minus 9k minus 19. Okay, then that is 81 divides 810q, tama, plus 90k plus 100 minus 9k minus 19. Okay, then simplify further, that this implies that 81 divides 810q plus 81k plus 81. Okay, ngayon, ano ba goal natin? Ang goal natin, that makita natin divisible tong part na to. Dapat, itong part na to divisible by 81. So, para masabi mong divisible by 81, dapat may factor siyang 81. So, ang gagawin, this implies that 81 divides 81 to factor out ko, then that is 10q plus k plus 1. So, napapansin mo, 81 divides 81 times 10q plus k plus 1. So, meaning, nagawa ko ng paraan na naging divisible to. So, kung napapansin nyo, sir, dapat sir, pag mathematical induction, mapakita mo na yung left side equal sa right side. No. So, pagdating sa divisibility, mapakita mo na dapat divisible siya. So kung sa k siya divisible, dapat sa k plus 1 divisible din siya. So, sa k plus 1, divisible din siya. So, therefore, pwede natin sabihin na, 81 divides 10n plus 1, okay, minus 9n minus 10. Okay, so this is by PMI. Okay, so ayun naman yung goal ni divisibility. Kung napansin nyo, in divisibility, naluan ko ng mathematical induction. So, hoping na nag-gets nyo yung idea nung topic na to. So, sorry, medyo mahirap. So, sabi ko nga sa inyo, habang tumatagal, pahirap siya ng pahirap. So, pag pinapabayaan mo sarili mo na hindi mag-aral, hindi siya intindihan, ikaw din mahihirapan lately. So, very useful to lahat Tandaan nyo. So, magagamit to sa may ibang subject someday. Okay, so that's all for this week. So, next week, wait tayo sa panibagong video. Okay, thank you.